Do you remember the steps of making an animation? Let's review them to see how this ball animation works. So first, outside of our draw function, we declare variables, whatever variables we want to use in the animation. In this program, we declare 4 variables: x, y, ball width, and ball height. Then inside our draw function, we use those variables and change them in some way. In this program, we use the variables to draw an ellipse, passing a variable for every parameter. And since we are passing a variable for every parameter, that means actually that we can animate every aspect of this ellipse. And that's just what we're doing. Look at that. So how are we changing those numbers? That's what we're doing with these lines of code here. On this line, we add 1 to x, which means that the ball moves 1 pixel to the right in every frame. On this line, we subtract 2 from y, which means that our ball moves 2 pixels up in every frame. See that? Now, on these lines, we're using some math operators that you may not have seen before. This star operator is how we multiply in JavaScript, and the slash operator is how we divide. So this expression here is taking the variable ball width and multiplying it by the fraction 99 over 100. Basically, it's making the width be 99% of what it was before. See? And we're doing the same thing on the next line, but with ball height. So each time ball height becomes 99% of what it was before. That means, just to show you the math, if ball height starts off at 200, then on the second frame, it'll be 198, because that's 99% of 200. See? All right, so we can see that this is the actual effect of our animation. Now, if you look at these 4 lines of code, you'll notice they all follow a similar pattern. We have a variable, then an equal sign, then that same variable again, then some math operator, and then some number. And you can see that in all 4 lines of code. This pattern is common in programming because we often take a variable and do some math operation to it and store the result in the same variable. Now, programmers, we don't like to do more work than necessary. So, a long time ago, programmers decided, hey, since we use this pattern so much, shouldn't there be an easier way to type it? So they invented shortcuts. I'll show you. Instead of writing x equals x plus 1, we can write x plus equals 1, and it'll do the same thing. Instead of this, y equals y minus 2, we can write y minus equals 2. Same thing. Here, we can replace this with times equal, and the same thing on the next line. And when we restart, we can see our animation is precisely the same. All we've done is use the shortcut to write the same expression in less code. There's also a divide equal shortcut if you want to divide instead. Ooh, look at that. That's weird. All right, so now that you know the shortcuts, you can write less code for the same beautiful result. And that is what we programmers love.